Okay, so I want to talk about a new file type, which is a file type called an STL, which stands, I think, for Standard Triangulation Language. So what this is going to amount to is the file that you need to make to put something into a 3D printer. So that said, that's wrong. Because 3D printers actually are basically an Arduino with servers, or servos, rather. So there's some kind of little computer control board and some motors. Right? We're going to go look at a couple and you'll see that this is what they're basically made out of. The Arduino that's in there, or the Mega, or whatever it is, like there's some little board in there. And the only thing that board knows how to do is execute what's called G-code. Okay? G-code is made by telling the, like, essentially, the x-axis motor is going to do this, the y-axis motor is going to do this, the z-axis motor is going to do this, and the extruder motor is going to do this. Right? So it's just a series of these little instructions, like XYZ extruder, XYZ extruder, XYZ extruder. And it operates on like a little bit like the loop command in processing. It's like 1/10 of a second or something. And it just does a new command every 1/10 of a second. And you won't be able to see it do each command because it kind of moves pretty fast, right? So that's how the 3D printer makes a thing. But I don't really think well in that. I think in like shapes. So my kind of go-to tool to make a shape is this thing called Tinkercad, which is dead easy. Okay, Tinkercad. Here's my account. I have bunches of little designs. I don't know what they are, but maybe this one is interesting. So Tinkercad kind of gives you cute little names right off the bat. And then on the right-hand side, I'm going to zoom this out a little bit. Come on. Make the interface smaller. Okay, apparently we're not going to make my interface smaller. Over here I have kind of basic shapes, right? And you just grab a shape and drag it out onto the deck. So like, okay, here's a square. I just lied to you. What is that thing? Yeah, that's a cube. It's 3-dimensional. And then there's some like control stuff here, right? Why is this so annoying? Really would like this to be zoomed back a little bit. Okay, slightly less annoying, but not much. So you can see that this shape here is kind of complicated, right? See this funny thing?
Square with a cube.
Yeah, it's some kind of cube with some kind of funny hole through it, and also this little leg, right? So this is a thing called a Prince Rupert's cube, which is a really interesting mathematical object. You can see one over here. This little red one over here doesn't have the bugger. This little red one over here doesn't have that little leg. And if you grab one of these, there's this ungroup command. Usually this goes the other way, right? Because you're going to build stuff. So I'm going to unbuild some stuff and just show you how things are made. So if I ungroup this, you can see that it's sort of a cube, right? That's this guy. The red dude is just a cube. And then there's this funny hole punched out of it. It should be noted that this hole that's punched out of it is 20 by 20 by 80. And the cube itself is 20 by 20. And when you group these up, you see that it doesn't cut that. The little red cube didn't get cut into 2 pieces. You see that it's actually all still one piece. The mathematical curiosity here is that you can cut a hole in a cube through which you can pass a cube of the same size that you started with. Which seems a little funky. In fact, you can do a little bit better than the same size. You can get like 6%, but it's really hard to make one. Right, because the little joints get thinner and thinner here, like this little dude. So this was me trying to 3D print one of these. So I just like went in and made this. This is not the point of this. This is just a tool you could use. So if you want to make things, you just grab shapes from over here, stick them together. If you stick them together with a hole, you can punch holes and stuff. That's cool, that. So let me talk about the result here. So I would like grab this thing and hit export, and there's an STL option. That's going to save an STL file to my computer. Then I'm going to show you what an STL file looks like. So this is an STL file called Tetra that is being, right now it's going to try to open with Cura. Cura is what's called a slicer. Yeah, a slicer. So let me show you what's actually in here. So I'm just going to open this with more apps. Notepad. Which is totally readable. It should be noted that that STL files come in two different kinds. There's two different ways to save an STL file. This is one saved in the readable way. If you download a file from, if you download an STL file from most resources, it won't be super readable like this, right? They'll be kind of that garbage that we got when we opened a JPEG, right? Because they're encoded with ASCII instead of in plain text, but whatever. So the idea of an STL file, though, is that it's got a solid, right? And then down here at the bottom, there's an end solid, right? So that's one shape, right? And this is kind of an XML style markup, right? You guys see that it's almost XML? Not quite, but almost. And then here there's facet and end facet. So a facet is one of the sides. And then there's this funny normal thing. Yeah, this is telling you which way is outside on this thing. And that obeys a thing called the right-hand rule. And if you took Calc 3, this would be like way more comprehensible. And then these are points, right? So there's a loop here. And that's going to go around the outside of a triangle. And it's got 3 points. So this one's at 0, 0, 0. And so that's at the origin. And then this is at 1 in the, which direction is that first direction?
Whatever the positive is.
Yeah, whatever positive is for that first direction. So traditionally when you write a 3-dimensional point, they're something, comma, something, comma, something. X, Y, then Z. So this is 1 out in the X direction, no back, and no up. Then this guy's no over, no back, and 1 up. You guys see that? So that's going from the origin, right 1, then 2 up, like from right 1 to up 1. That's kind of a diagonal. And then back to the origin. You guys see that? Then here's another one, right? And it's just got a normal, and then it goes from 0, 0, 0 to 1 back, and then to 1 in the X. So that's going to be the bottom. This was like the front, bottom. And then there's this one's from the origin to up 1 to back 1. So that's like left-hand side. And then this one's a little confusing because this one goes from over 1 to back 1 to up 1. So that's, yeah, that one's a little bit dorky. Let's just open it in Cura and see what it looks like. So Cura is a slicer, which means that what it does is it takes triangles, like sets of triangles, STL files, and turns them into code for the 3D printer. Okay? So you have an idea in your head. You use a CAD program to make that into an STL file. Then you feed the STL file to a slicer that makes it into G code. And then you feed the G code into the printer, which makes it into an object. Does that kind of follow a little bit? It seems really complicated, right? Okay. Well, fine, whatever. Where's my shape? File, open. Desktop, Tetra, okay. Auto scale to, oh, there it is. You guys see it?
Oh, that's adorable.
Oh my god, it's tiny. Why is it so tiny? Yeah, it's going 1 millimeter up, over, and back. So I'm probably gonna want to scale that. So I opened 2, so I'm gonna delete 1 and grab this one. And then in the, oh my god, why is my, I'm sorry, this display setting sucks. Okay. Sorry, it's going to be harder to read text, but maybe not much harder. Okay, so I have my little STL file here, which is mega tiny, right? And you could, like, oh, I screwed it up, go back to CAD, scale everything up, re-download it, reopen it, or you could just grab the scale function in here and be like, yeah, I'm going to need to scale this a lot, right? Oh, and you'll notice here, down at the bottom, it says it already scaled it to 10,000%. So I lied to you when I said it was a millimeter by a millimeter by a millimeter. It was like a nanometer by a nanometer by a nanometer or some tiny little bit. But we can just zoom it. And you want to keep the uniform scaling on if you don't want to distort your shape.
Just change your unit size.
Yeah, and you can change the default units too. And you won't have this problem if you don't write an STL by hand. If you write it in CAD, it'll keep the units with it most of the time. Every once in a while, you'll find a shape that somebody coded in millimeters, coded in inches, but left the millimeter tag in there, and it'll show up mega tiny. So there's my kind of shape, right? And now you could add in your like custom print settings over here. You can set things like how thick are the walls, like how high are the layers, what infill percentage am I doing, what material am I printing in, like what temperatures do I want things to be, right? The infill is interesting in that this, where's my layer view? Layer view. So if I go to layer view here, and then scroll down through the layers, you guys see how this thing's kind of hollow? Why is it hollow?
Save on resources.
Yeah, you just save some plastic, right? May as well be hollow. If you want to make it not hollow, what do?
I mentioned setting for that.
Yeah, you can go over to infill, right? And right now the infill density is set to 22% for some reason. If I set it to 100%, it'll reslice. So now it remade instructions for the printer, right? And now it's basically filled in. And you can see kind of, let me get rid of that raft. So that raft is under build print. So this thing here, that's to keep it stuck to the bed. So if I just turn that off, that whole thing should go away. I'll slice again. Okay, now you can see kind of what it's doing in there. Let me scale this up some more so we can. Yeah, I scaled it way up so that I could play with the layers. It should be noted that you wouldn't want to print anything this big on the printer that it's using here. So right now you can see it's doing, see it's got 3 layers around the outside. That's kind of these 3 layers here. So it's tracing the exterior, boop, 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 3 times around. And then it's just scribbling in the inside to fill it up. If I change the infill density back down to something more reasonable, like say 10%. Oops.
1%.
Okay, if I change it back down to 1%.
One line is what.
Yeah, so
I hope it holds together. It's probably fine.
yeah, and on this shape, that's probably fine. Like, it depends a lot on the shape, right? If I set it to 10%, it'll fill this with some kind of little grid. Right? And depending on the slicer and depending on the settings in this slicer, you can change that from lines, like, or grid like this, to like hexagons or to something else. Let's see. And if I hit show travels, it won't be interesting on this one. So the show travels is going to show where the 3D print head picks up. So you can see there's this little blue line back over here in the corner. See that little tiny bit of blue line back there? That's where the printer's moving its head, but isn't actually extruding anything. Right, where it's just repositioning itself. If I had a more interesting file, like with a couple towers or something, we'd see lots of kind of jig-jogging in between. Let me pause this and get them ready. Okay, so let me not pause it and show you how I would get a different file. So like, if I didn't want to design a file, Thingiverse is a really nice resource. So you just go to Thingiverse, right? And then, let's see, I want something interesting, so I'm going to go get a Klein bottle. And this is just basically open source, like people have designed things and then uploaded them. So some of these are kind of rad. I don't know. Maybe I'll just grab this one because I've printed this one before and I know it works really well. So I might go over to Thing Files. Right? So in Thing Details, people will often be nice enough to tell you something like what they printed it with. So like this guy says he printed it with 0.15 millimeter layer height, 0.5 millimeter nozzle, no support, no infill. For better adhesion, he stuck some Kapton tape on his print bed, which is a pretty common thing to do. Basically because if you're printing and it pops off the bed, it kind of sucks. Like it just drags it around and starts extruding plastic in the air where it should be extruding plastic, but it's not extruding the plastic onto anything. It's just like, it looks like a children's disaster with a hot glue gun. Okay, so if you want to get this file, you just go in here and you can download one of them. Like he's got two versions. He's got one with a little bed support or bed adhesion stuff added to it and one without. I'm going to open it in a slicer anyway, so I don't really need his bed adhesion. Oh, there's another file I was working on. That's teeth for the Roomba, by the way. So that the Roomba can climb up over stuff. So I want to delete this model and open a different one. So I'm going to go into Open Files. And then Downloads. And I wanted the Klein bottle. Because they'll get stuck on stuff. There was a point for the teeth. Trust me. Oh, there's some traveling. Right? So all the blue stuff is where the printer's moving around without extruding plastic. If I get rid of that, you can see this kind of thing. And if I layer down a ways, you can see that it's not really infilling anything. You guys see that? Like these are basically solid. They have just a tiny little hole on the inside, maybe. Oh, that's not even a hole. So this is one layer around the outside, fill in the inside with just a little bit of plastic, right? And so those are basically solid. They're not thick enough to need infill in them, and so they just don't get any. And if I turn travel back on, I'll see that it does, like, if I look really closely at one of these, like this one. So it comes over here and it does a whooped around, and then it travels across and goes somewhere. Up, looks like. That looks like that's the last one. Oh, no, it pulls up on each one. Why would it pull up on each one?
Go to the next level?
Yeah, so it's going to do all of those at the same level, but it probably lifts up just a little bit so it doesn't tip it over. You guys see that? That's just a setting in here. We could probably change that if we really went deeply into Cura's code. Cura is actually open source, so you can download the source code for Cura, which is probably written in, I don't know, C.
All that is straight rectangles.
Yeah, and the 3D printer is basically good at rectangular things. You'll notice that this chunk here has some slightly curvier bits. See this slightly curvy bit here? And then this thing is basically made out of these kind of rectangles. That's one of two things. That's probably the file itself has straight lines there. It's also possible that the when this was sliced, it made things a little straighter. Right? It's going to make things a little straighter on some scale. I think that scale is way, way smaller than what we're seeing here. But it's possible that the slicer did a little bit of straightening out. Because the STL file was just a whole crap load of triangles, right? Like when I downloaded this, it was literally just many thousands of triangles. And then the slicer went through and said, okay, so if I'm going to have those triangles made out of plastic, I'm going to need to do this, this, and this. And then it kind of wrote G-code for that. And if we want to view some G-code, let's see. So, oh God. Oops. Let's see. So, give me 1 sec. Okay, so I took my model here and saved the G-code for it out of Cura. Right, so this is the G-code for the Klein bottle. And you can see up here that there's some like header stuff, right? Bigger. Yeah, I can make things bigger. Maybe. This is gonna get annoying again.
Sorry.
And we just let what?
Up!
Oh.
Yeah, that's beautiful.
Hooray! Bigger! Okay. So okay. So if you look at this, we've got flavors Marlin. Here's a time in seconds? I don't know. How many? I don't know.
Calculator.
Get a calculator. Get some math. Get out your algebra 0. That's like, yeah, it's a unit conversion, right? It's probably seconds.
9.3 meters.
So it used 9.3 meters of plastic, it seems to think. The layer height is...
That's 6 hours.
Yeah, that's about right. So this is a 6-hour print, which is fairly long, but not crazy long.
It only goes through 9 meters in 6 hours.
Yeah, you have to remember that most of the Klein bottle is empty, right? And also, this also had the supports on that we were looking at for a second. So there's a lot more plastic used, actually, and it takes longer, right? So 9 meters of plastic is not very much plastic in the grand scheme of things. Let's see. So then I've got generated with Cura, and then we've got some little, like, bits and bobs, right? And then this is the G code that's being executed, right? So this first thing tells the printer that it's going in absolute extrusion mode, that everything's in metric, that it's using absolute positioning. Then it's setting this thing to absolute printer or absolute mode. Then it's starting with the fan off. It's homing the printer. So what that's doing is sending everything to 0, 0, 0. And we're going to see that there's going to be a switch on the printer, and it's going to go until it hits the switch in one direction, and then it's going to go until it hits the switch in another, and then it's going to go until it hits the switch in the last direction, right? And then there's some like, okay, so it moves up and heats the nozzle up, It moves over to the edge of the print bed. It draws a little wiping line, right? And so these little bits here are telling it about the kind of Y position and the extruder, and then some other stuff, right? And then if I scroll down here, like this line is telling it move to this spot in the X and this spot in the Y and extrude. And then this line is telling it move to this other slightly different spot in the X and slightly different spot in the Y and also extrude.
So it keeps it kind of the total extrusion.
Yeah. So that's like the E values are the extruder, the Y values are the Y code, the X values are the X code, right?
G1 is the slice that you're on.
Yeah, and so G1 is telling it this is the mode you're in. So right now you're in like move around mode, basically. So then if we go, let's see, I want to find one with a Z. Okay, so this one's clearly different, right? These ones are kind of different. So that's a pick up and move. See, there's no extrude in those lines. So that's probably where it transitions from line to line. Yeah, and it's kind of got a different mode, right? So that G0 is probably, it's now moving vertically or something. We could look it up, right? So if I wanted to know for sure, I'd just be like, okay, Google. G0, oh god, G code. G0 versus G1. Come on. I know. That's what I was doing. See? I'm clicking it a lot. Okay, anyway. So it says, all right, G0 and G1 are both move modes. G0 is rapid and G1 is linear. Right? So if G0 is rapid, that's probably changing things really quick. That's moving between chunks of the print. Like just, yo, dude, get over there as fast as you can. And G1's like, careful now, you're actually printing things. You guys see that? Okay, and then we could go all the way through this whole business. Let's see. Oh, cool, look. So there's G4, which is dwell, which is like, yeah, like just go chill over there for a second. You might do that if you were interested in bridging or something. You might like bridge and then sit there a second and give that plastic a second to cool off before you go back across it. Yeah, so there's obviously whole bunches of stuff you could know about G-code. Yeah, and we could totally write our own G-code, right? Like you could actually write this stuff. It's not impossible. It opens in Notepad, which is really convenient. So you can make some G-code for something, look at it, figure out what's up, and then write your own if you want to. And lots of people end up writing their own. So, for instance, I need to write a little bit of my own because I really, god damn it, go up to the top. That was a really great spot for paid job. So quick. Or home. So what I really need on one of the printers that we have in the print lab is I need this part. This thing. Why do I need this thing? What's this part of the code do?
Make sure you don't hit anything.
Just gets plastic going and wipes a little bit of plastic on the side of the printer. So when I show you this, you'll see it, like, we'll go over there and we'll see why I want to add that piece of G code. And this is not quite the one I want because this doesn't do exactly the thing I want, but it gives me a clue as to how to get it to do exactly what I want. So that's one of my projects for like this afternoon or whatever.